Okay, for this one is the design, WLAN networks design and configuration. This only has one session. So how we can design a WLAN? So first thing we need to know there are two forwarding mode of this WLAN. There's two mode. One is bridge mode, one is tunnel mode. The bridge mode is like controller provide the central management, or configuration for the APs. The control data and the service data is separated. Lots of the cloud-based solutions, it just give you the AP and you deploy the AP locally. Yeah, this is the mode they support. They only support this mode, bridge mode, because they only can manage the AP. The control data and the server data is totally separate. That is the bridge mode. The tunnel mode is the controller and the AP build up a data tunnel. So at the points, or also can see the stations, data will be separate from the AP to the controller in a tunnel. So for tunnel mode, I think it's only local controllers support. Because for the cloud-based, the cloud controller is provided by the other vendors. So if they can support if the client need a tunnel mode, they cannot put all the data go to their cloud controllers. So the tunnel mode is the only local controller support. So for this tunnel mode, we have the advantage. Later we can see the advantage. So the bridge mode only have the control tunnels. Yeah, the user data go to the internet directly. Yeah, this is the bridge mode. So after this, I think you have the you just totally understand what is the bridge mode. Yeah, for the tunnel mode, between the AP and the controller, you have a control tunnel and also have a service data tunnels. So the package from the stations go to the AP first. From AP, you can see the AP will end a tunnel head. It will end a tunnel head. That's why we call it the tunnel mode. For example, the source IP address of this package is the AP. Is a station. When it arrives at the AP will change the source IP address to themselves, to the AP and the destination IP address to the controller. So this is the tunnel. Definitely they will add something, add new head to this package. So we add this package go into the controller, and then our controller remove this tunnel hand, and then the service data be transferred into the internet. So this is the tunnel. This is the tunnel mode. This is tunnel mode. Sorry, the title here is wrong. Also, we have the mixed mode. Actually, the mixed mode is not a separated mode. It's just a scenario for use. For this one, because for some client, actually almost all the client, they will have the different SSID. So maybe they have one AP, you have two SSID. One SSID for the office, for the staff, and another SSID is for the guest. So two SSID in a different mode. So for one AP, we see this AP is in the mixed mode. This is easy to understand. So there have what is advantage and disadvantage for the different mode. For the tunnel mode, for the bridge mode, it's like the advantage is the controller is work very easily. You don't have to work very hard, and even there's the downtime because the traffic not go to the controller. We can still have disaster recovery. We just let the AP broadcast the SSID. So for the users, there's no downtime. So the disadvantage is the roaming effect. That the experience is not good as in the tunnel mode. And also the function is not that complete. They can, once you can see from the audit, they cannot audit the content. And also in the tunnel mode, it have the four advantages. It has the four functions and a good roaming effect, and also very flexible for network planning and easy to expand the new functions. Because in the tunnel mode, all the traffic going to the controller. Actually, it's also more secure. Think about it. If we have a network, we provide the guest Wi-Fi. If we only support the bridge mode, the users, the guest traffic going to our network, and maybe we'll find our servers or something. But if we use the tunnel mode for the guest traffic, we only let this data go into the tunnel, go into these tunnels from the AP to the controllers. So there's a specific tunnel, so this is more secure also. And then it's the disadvantage of the tunnel mode is have the single point of failure, because all the traffic goes through the controller. So if the controller is down, so the traffic nowhere to go. So we have the HA to solve this problem. So we can use two controller for the HA. And also, because all the traffic go to the controller, it's also will have the requirement for the controller's throughput. So in this condition, we can just avoid to deploy the AP use the single arm. I'm not sure if you know the single arm. The single arm structure is like we just use the one cable connect to the another devices. We use this cable, we forwarded the data, and then the data come back through the same cable. This is the single arm. So if we want to avoid the throughput limitation, so we can use the two interface, at least two interface, one port for the going to the switch, another port for the go out. So also we can do the like leak aggregations. That's another thing. So here we can have configuration cases for the different mode. This is almost same with the case we configured before in the previous slides. So you can see that this is the network after we add our WLAN products. We add one AP and one controllers in this network. So right now we chose to configure it in the bridge mode or tunnel mode. But first, let's configure this like interface, routes. This is a very basic configuration first. After this, we approve the AP. So now it's time to configure the SSID. When we configure the SSID, we can configure it in the bridge mode. First, we configure in the bridge mode. In the bridge mode, we just have a SSID and choose in the bridge mode. And here we can just assign the VLAN 1. Assign the VLAN 1. Why we assign the VLAN 1? What will happen if we assign the VLAN 1? If we assign the VLAN 1, the users will get the same IP address with the AP's IP address. Same IP address in the same subnets with the AP. This is VLAN 1. And in the tunnel mode, it's like this is our top logic, and we need the traffic go to the controller first. So and also the station is VLAN 10. So we need to create interface VLAN 10 inside our controllers. So we create a SSID tunnel mode and assign the VLAN 10 to this client, to the stations. Here is the notes for this deployment. So in a tunnel mode, because all the data we was forwarded by the controller, so it will increase the throughput a lot of the devices. And also in the in tunnel mode, in tunnel mode, we definitely need to create the interface VLAN. We need to create the interface VLAN and enable the DHCP servers. Because we have the tunnel mode, we will configure SSID, and then we assign the VLAN 1. So they will try to get IP address from this controller. So if we don't have the IP address inside of this, if we don't have DHCP server for this VLAN inside of the controller, actually the stations cannot connect to our network. And also in the tunnel mode, the stations cannot get the IP address from layer 3 interface because we started the IP address of the VLAN, the faulted VLAN, so they cannot get IP address from layer 3 interface, even we have the DHCP server in the layer 3 interface. Okay, in the bridge mode, we need to make sure because in the bridge mode, when we have the multiple VLANs, in the scenario we have the multiple VLANs, we need to make sure the switch that connect to our AP is also in the truck mode. If that, because that traffic is directly go to the switch, go to the upper network. So we need to make sure that VLAN can be identified by the user's existing network. If their network is not allowed other VLANs, and we configure this SSID another VLANs, actually we cannot get IP address. If we get the IP address, we cannot go through their network. And also in the bridge mode, if we want to obtain the IP address on the same network segments with the AP, we only cite the VLAN 1. Why we cite the VLAN 1? Because for our AP's uplink is the truck and the native VLAN is 1. So when the data go out from our APs, this tag will be removed. The VLAN 1 tag will be removed. When the data go into the switch, it's just like a package without any tag. Okay, now let's see the different deployment scenario for our project. Let's see the local deployment. The local deployment is we have the controller in the local LAN. You can say that this is the before deployment. We have a router, switch, and APs, and then we deploy it. We deploy it one controller, and now it's in the bridge mode, and this is a layer 2. So this is very easy. It's very easy for us to manage the network because the AP will automatically discovered by the controller. This is control tunnels. This is a control tunnel between the AP and the controllers. So when we have network, we make sure the AP and the controller, they have the IP address, the same subnets, they can talk to each other. Yeah, this user's network. So the bridge mode, in the layer 2 tunnel mode. In this tunnel mode, the AP and the controller first will build up a control tunnel, and also they will build up data tunnels. So the data server data tunnel, you also go through this. So this is a layer 2. For layer 2 and the layer 3, just layer 2 is very easy. So for the layer 3, it's a little bit different. Network is a little bit large. So the AP and the controller in the different subnets. So how they can talk to each other. So in this situation, we need to consider about other ways for AP to discover the controller. Usually you can use like the option 43, or we can use the the DNS. We can use the DNS because their network is large. Maybe they have hundreds of APs. We cannot configure it one by one, or yeah, this will be time consuming and also not convenient. So once we need to, when we use the bridge mode, all the ports that connect to the APs are better to be the truck, because we will use a multiple VLANs, and the multiple VLAN should be allowed on that port. So that's why we use the truck. And in the tunnel mode is last time is easy for the deployment. Why? Because for the tunnel mode, we only need to care about the IP address, how we can find the controllers. So as long as these controllers be fired by the AP will be managed, and then we can create the SSID. All the DHCP servers always in our controllers. So we actually we don't need to care too much about users network. For the port to our AP's access port is enough. So that's easy for to do the deployment. Because in the layer 3 access mode, layer 3 bridge mode, for the user's network, you need to do the communication with the client, like which port should be the access, which port should be the truck. This will cost lots of time. Sometimes the customer already forget what they configured for the switch. So if that bridge mode only the access port, that's what we like. As long as the IP address is okay, all the traffic from the AP to the controller, so that will be very easy. And that's why it's the remote deployment. For the remote deployment, we have the two scenario. First one is from the branch to the headquarters. The client already has the VPN or the private line. So in this situation, actually for our Wi-Fi project, it's like layer 3 deployment, local layer 3 deployment, because these two network already be connected by the other VPN solutions, maybe software VPN, maybe the Cisco's IPsec VPN. So they already have this, they already in the local LAN by this by this VPN service. So we just consider it is a local deployment. We no need to use the public IP address in our controllers. No need, because we already have the VPN service. Another way is the another situation is the client want to do the remote deployment, but they don't have existing VPN set up. So they want to use our controller and in headquarter and AP the branch only. So we need to, in this issue, we need to do the port mapping for our controllers. This we also can give a public IP address. If the client have the public IP address, we can configure a public IP address to our controller. If they don't have, we can do the port mapping in the controllers. In the port mapping, we need to do the port mapping like UDP 777, UDP 7077, another two port 5246 and 5247. This is a standby for these ports. You can do it port mapping for this one. If the UDP 7077 is blocked, another two port will work. If you just do the UDP 7077, it's also okay, no problem. And then is the TCP 7070. This is for the control tunnel. And then TCP 8 that's download, and the TCP 70, this one is optional because this one is not related with the remote connection. This is just for your management. You can change this if the TCP 443 is being occupied by other servers, other devices. You can choose another port. Okay, there's last two. We have two different scenario. One is the HA. For the HAs, the setup is like this. We have the one heartbeat line between our controllers and uplink port and the VRP. If you know the VRP, I think yesterday we already. No, I have it because in the switch we also have VRP, the same protocol. And also the VRP is the universal protocols. So the uplink is to VRP port. So we two devices, you have one virtualized IP address. And one is master, one is a standby. So if one is down, the other one will become master. And for this heartbeat line, it synchronizes the configuration and also some database standards. So that is HA. For our clients right now, because as you can see that our solution is controllers, switches, and the APs. We provide the almost whole solutions for the users access wired and wireless. In this situation, for the project, we can recommend to them to use the HA. Why not? Because the controller, we only need to manage one controller, and this controller is extremely important to our network, so better have a backup. And another scenario is the CM cluster management. For this one, is like we use the controllers to manage the controllers, and also the controllers in the headquarters and branches can be back up to each other. So for this one, if we want to do this for the headquarter controllers, CMC controllers, we need to do the port mapping or the TCP 500 and the UDP TCP 5000 and UDP 5000 and TCP 7000, TCP 70,000 and TCP 71,000. So this port have the for example this one TCP 5000 is used to the tunnel connection between the CMC controller to the site controllers for the management, and also is for the data synchronize. And TCP is like if you in the headquarter controllers, you want in the headquarter in the CMC controllers, the controller head in the headquarter, you check that bridge controllers. You check the bridge controllers. You can directly go to the bridge controllers managing web. So that this is the port. This is a group of the ports they are using for that management. Because imagine that if from one controller you use other controllers web UI, actually you need to build up lots of the sessions. So that's why we use 1,000 ports. So, and the others, if you want the headquarter controllers to do the backup for the APs, take over the APs. If the branch's AP is down and you want the AP be taken over by this control AP in the headquarters, so you also need to do the port mapping for the AP management. For the AP, just like same with the remote deployment, this 4 port. For the configuration of VRP and CM, we haven't included these junior sessions. So we don't have exam content for the CM and the VRP configuration, but for some terms, we maybe have the question in this part. So we can have the more detailed explanation about the VRP and the CM configuration in the senior level training, SCWP. Okay, now